Tonight, settle into a quiet history of fire as one of the oldest ways people thought about change. Imagine one small, controlled flame in a dark room, the kind that can rest safely in a clay lamp or a sheltered candle glass. It is not a great blaze racing through wood, and it is not a dangerous fire spreading beyond its place. Just a little point of light in a clay lamp, or a low piece of flame moving over a wick. It leans slightly when the air moves. It gathers itself again when the room becomes still. Its edge is never quite in the same place twice, and yet we keep calling it the same flame. This is one reason fire became so useful for thinking. It seems simple at first. A flame is something we can see directly, but it is also something we feel before we fully understand it. It warms the hand, lights the room, and changes the space around it. It eats fuel and leaves ash. But when we stay with it, even quietly, it becomes difficult to describe. It is visible, but it is never still. It has a shape, but the shape is always changing. It is fed by matter, but it does not look like the wood or oil that feeds it. It is useful, but it is never fully tame. Long before fire was explained as combustion, people could watch it transform the world in ordinary, visible ways. Wet wood hissed as its moisture escaped. Clay hardened into a vessel, and food changed texture as heat moved through it. In a furnace, ore changed color, hidden metal became workable, and solid material softened until it could be shaped. These changes made fire feel less like an object and more like an active process. A dark room became readable. A cold room became livable. A body that shivered could rest near warmth. Fire did not merely sit among other things as a stone or bowl might sit on a table. It acted on nearby materials by drying them, blackening them, warming them, melting them, or turning them into smoke and ash. Because those changes were so visible, fire became a natural image for change itself. From there, the history can move slowly through fire as an idea. Older belief will not be treated as modern science. Symbolic meaning and chemical explanation will not be forced into the same kind of truth. Instead, older systems can be heard in their own terms, and later experiments can gently change the story. There will be philosophers here: Heraclitus, thinking through fire and exchange; Empedocles, setting fire among the four roots of things; Plato, trying to place fire in an ordered cosmos; Aristotle, giving fire a place among qualities such as hot and dry. There will be Stoics, for whom fire and breath helped explain a living world. There will be sacred fires, carefully tended. There will be furnaces, alchemists, safety lamps, gases, and the slow discovery that ordinary flame depends on something within the air. But before all of that, there is the small flame. It does not need to speak. It changes as we watch it. It continues only when there is fuel to feed it and enough air moving around it. In return, it gives light and heat, but it also marks the edge between useful care and possible danger. If it is neglected, it goes out. If it is fed too much or given too much room, it may grow beyond its proper place and become difficult to control. The old task is not to own fire completely, but to tend it with attention, distance, and limits. This is a quiet beginning for metaphysics, not an abstract argument, but a careful observation of something ordinary that keeps changing while still remaining recognizable. A flame is not the same shape from one moment to the next. Its edge leans, folds, narrows, brightens, and returns, while the mind still recognizes one continuing flame. That is the clearer thought. Some things remain identifiable, not because they are frozen in place, but because their change follows a pattern we can recognize. A flame is a good beginning because it does not let the mind settle too quickly. If we call it a thing, it behaves like an event. If we call it an event, it gathers itself into a visible shape. If we call it light, it reminds us that it is also heat. If we call it heat, it reminds us that it also consumes. It is simple enough for a child to notice, and difficult enough for centuries of thinkers to interpret. There is a small lesson in the way a person approaches a flame. The hand does not move carelessly. The eye watches the edge. The body understands distance before the mind gives distance a name. Too close, and warmth becomes pain. Too far, and warmth disappears. Fire teaches proportion before philosophy begins to speak of proportion. In a dark room, one lamp can make order appear. The table separates from the wall. A cup becomes visible. A face, if someone is present, emerges from shadow. But the lamp does not illuminate everything equally. It creates a circle of knowledge and a larger border of uncertainty. A flame is a teacher of limits as much as a teacher of light. That may be why fire has so often carried metaphysical weight. It does not merely show that things exist. It shows that things appear, vanish, alter, and depend on conditions. It teaches that presence is fragile. It teaches that brightness has a cost. The fuel is not unchanged after the flame has passed through it. The modern word combustion gives us one kind of explanation. It is a powerful explanation that belongs later in the story. But a chemical explanation does not erase the older human encounter. A person who understands oxygen can still feel the old pull of a candle flame. Knowledge changes the meaning of wonder, but it does not always remove it. So the beginning stays slow. There is no need to hurry toward a final definition of fire. It is enough to watch how many kinds of questions one flame can open. When wood becomes heat, light, smoke, and ash, it raises a question about what change really means. When the flame keeps its identity while its shape constantly moves, it raises a question about what remains through transformation. Fire also asks whether danger can become useful when it is bounded by care. It asks whether visible events such as burning, warming, and darkening might point toward an order that cannot be seen directly. The history of fire is one long attempt to answer these questions in different languages. A flame also teaches condition. It is not enough for fuel to exist. The fuel must be dry enough, shaped enough, near enough, and open enough to air. A heavy log dropped on a tiny ember may smother it. A few thin shavings may help it grow. Damp wood may hiss and smoke before it gives itself to flame. Too much wind may scatter sparks, but a gentle draft may strengthen the burn. Long before anyone spoke of oxygen, people knew these practical truths. They knew that fire liked some materials more than others. They knew that a covered coal could survive through the night. They knew that ashes could hide heat after the visible flame was gone. They knew that a fire could seem dead and then wake again when stirred. This kind of knowledge is not yet chemistry, but it is not nothing. It is the knowledge of hands, eyes, and repeated evenings. It is the knowledge of a person who has built a fire badly and watched smoke fill the room, then built it better and watched the flame rise cleanly. The history of fire begins in that kind of attention. Philosophy often begins after ordinary life has already learned something. The hearth learns before the school speaks. The workshop learns before the treatise organizes. The cook, the potter, the smith, the keeper of a lamp, and the person warming a room all know that fire is never simply present. This is why fire can feel like a thought about dependence. It depends on fuel that can burn, air that can reach it, and enough distance from other materials to keep it controlled. It also depends on the vessel, the hearth, the hand that tends it, the weather outside, and the hour of the night. It is active but not independent. It is powerful but conditional. That conditional power is one of the quiet themes of the night. Fire changes architecture, even when the room is simple. A house with a hearth has a center. A room with a lamp has a circle of light. A workshop with a furnace has a place that must be respected. A temple flame changes the meaning of the chamber around it. Even a miner's lamp, small enough to carry in the hand, creates a moving boundary between sight and danger. This gives us another quiet thread. Fire creates inside and outside. Inside the circle of light, people can work. Outside it, darkness remains. Inside the hearth, flame is food, warmth, and routine. Outside the hearth, the same flame may become disaster. Inside the lamp, fire is useful. Outside the lamp, oil and cloth and wood may catch. Inside the ritual vessel, flame is approached with order. Outside that order, it would be merely burning. Inside the safety lamp, fire can help a miner see. Outside the gauze, in the wrong atmosphere, it can ignite fire damp. This pattern belongs naturally to metaphysics because boundaries help things become what they are. A flame without a boundary is not a hearth fire, or a lamp flame, or a furnace heat, or a ritual light. It is only burning. Human meaning often begins when power is given form. So the question returns in a more practical form. What holds fire? Across history, the answer changes from clay lamps and stone hearths to metal furnaces, glass chimneys, and wire gauze safety lamps. A theory can also hold fire by explaining it. A ritual can hold fire by giving it rules. And a story can hold fire by placing it inside memory and meaning. A scientific explanation holds fire in a different way, by describing fuel, heat, gases, and reaction. Every holder changes the fire's meaning because every boundary changes what fire is allowed to do. Fire can also quietly gesture toward the other elements without hurrying away from itself. Fire is our beginning because it makes change visible. Water will later let us think about flow, depth, dissolution, and life. Air, or wind in the language of the title, will let us think about breath, invisibility, motion, and the unseen medium around living things. Earth will let us think about weight, stability, place, body, soil, and matter. But fire comes first because it refuses stillness. It lets the listener imagine transformation happening at the edge of the hand. A piece of wood does not stay wood. Oil does not stay oil. A dark room does not stay dark. The world before the flame and the world after the flame are not the same. The order is not arbitrary. Fire begins because it makes change visible. The four elements become four doors into one old question. What is the world made of, and why does it change? The old answers differ from modern science, but the question remains large, simple, and strangely restful. Before fire became a word in philosophy, it was part of daily work. It kept bodies warm in cold rooms, softened food in pots or over embers, and made the evening usable after daylight was gone. It was the work of seeing after dark, hardening clay, clearing land, shaping metal, boiling water, drying cloth, and keeping insects or animals away from a sleeping place. A hearth was not only a decoration. In many households, it was the center of routine. It needed fuel. It needed ash cleared away. It needed a space around it that could survive heat. A fire could be covered and banked so that embers remained alive through the night. In the morning, those embers could be coaxed back into flame. The first work of the day could begin with a careful breath and a small glow. This kind of fire teaches slowness. It teaches that useful power is not always loud. A small ember can become a cooking fire. A cooking fire can become too large. A flame can be carried, shared, protected, or lost. Its usefulness depends on boundaries. That is part of the old intimacy of fire. It is not simply good, and it is not simply bad. It warms the house and can burn the house. It makes tools and can destroy tools. It purifies in one setting and consumes in another. It gives human beings evening, but it also makes them watchful. From such daily experience, it is not difficult to understand why fire became more than one thing in the mind. It could be a warning. It could be a sign of divine presence, or craft knowledge, or social life. It could belong to the kitchen, the forge, the altar, the kiln, the funeral pyre, and the philosopher's image of the world. The same visible process appeared in many places. In a kitchen, flame changed raw food into something easier to eat. In a forge, fire changed ore and metal, drawing out possibilities that were hidden in stone. In a kiln, it changed wet clay into pottery that could hold water. In a lamp, it changed oil into light. In a field or forest, it could clear, scar, destroy, renew, or leave behind a dark soil. For a person watching without modern chemistry, fire could look like a kind of active principle. It moved upward through the air, brightened the space around it, spread when fuel was available, and consumed what it touched. It separated one state from another. It made before and after visible. This does not mean that ancient people were confused in some simple way. They were working with the evidence available to sight, touch, craft, and inherited explanation. The flame was real. Its transformations were real. The pattern of tending it was real. What changed later was not the importance of fire, but the tools and language used to explain it. We can stay with the hearth a little longer. A low fire at night is not only a source of heat. It changes time. It lets a room remain awake after the sun is gone. It gathers people nearby. It makes faces visible. It makes shadows move. It can turn the wall into a surface of wavering forms. It can make silence feel occupied. In that sense, fire was also a maker of inwardness. Near a flame, a person can work, remember, pray, tell a story, mend a tool, or simply watch. The outside dark remains outside. The small ring of light becomes a world. The philosopher does not begin very far from this. The philosopher looks at the same flame and asks what kind of thing it is. Is it a substance? Is it a process? Is it an element? Is it a sign of change? Is it part of the order of the cosmos? Is it only burning matter? Is it a doorway into the way human beings imagine transformation? The history of fire is full of answers to those questions. Some are practical, some are poetic. Some belong to ritual, some to craft, and some to metaphysics. We begin with the simplest observation. Fire is never merely an object. It is an event that must be sustained. The hearth also teaches memory. A cold hearth and a warm hearth do not feel like the same room. Ash holds the record of what has been burned. Charred wood shows where heat passed. Smoke darkens beams over time, and soot gathers in corners where the air carries it. Even after the flame is gone, fire leaves evidence. This mattered in everyday life. A household that could preserve embers saved labor. A household that lost fire had to rekindle it or borrow it. Fire could move through a community as a practical gift, a coal carried from one place to another, a light taken from an existing flame, a warmth shared. These are small acts, but small acts are often where durable ideas begin. Fire is not only an element in a philosophical diagram. It is a dependency. It links people to fuel, weather, tools, labor, and one another. It also links human beings to time. A flame takes time to catch. Bread takes time to bake. Clay takes time to fire. Metal takes time to heat and hammer. A lamp takes time to burn down its oil. Fire has a tempo, and people who rely on it learn that tempo. This is one reason fire works so well for quiet night listening. It is not only visually calm when controlled. It asks for tending, waiting, checking, adding, covering, uncovering, and watching again. It turns work into rhythm, but the same repetition can become anxiety when conditions change. A spark in straw is not a hearth. A roof beam catching is not warmth. A lamp tipped over is not light, but danger. Fire can leave its assigned place, and when it does, the same power that made life easier can become destructive. That double nature is crucial. Fire is not morally one thing. It becomes helpful or harmful, partly by relation, boundary, and care. The hearth contains it. The forge directs it. The kiln encloses it. The lamp feeds it slowly. The ritual vessel honors it. The safety lamp restrains it. Fire becomes meaningful through the form that holds it. This gives the history a quiet, recurring pattern. Fire plus boundary. The wick limits the small flame of a lamp. The hearth keeps household fire in one place, and the furnace concentrates heat for work. The altar bounds fire through ritual order, rather than through engineering alone. The gauze of a safety lamp bounds it. The chemist's glass vessel bounds it. The philosophical concept also tries to bound it, giving it a name and a place within the order of things. Because this history touches fire, lamps, mines, furnaces, and gases, it includes a quiet, safety-minded reminder. Fire is beautiful in memory and thought, but in ordinary life, it remains a real danger, and every useful flame depends on proper ventilation, distance, material, and care. It does not need to become loud. It simply makes clear that we are not romanticizing risk. The same care applies when we reach oxygen. Oxygen-rich environments can make combustion more intense, but this is historical explanation, not a set of instructions. There is no need to explain how to make oxygen, collect gases, or reproduce old experiments. The useful thing is to understand what happened historically. This is educational history, not a demonstration guide. There are no instructions here for reproducing old fire or gas experiments. Before Heraclitus, other early Greek thinkers had already asked what lies beneath the changing world. The details are debated, and the surviving evidence is thin, but the question is clear enough. Is there one underlying source of things? Is there a basic stuff, or a basic principle, from which the variety of the world can be understood? Water, the boundless, air, number, being, becoming. Early philosophy moved through such possibilities slowly and unevenly. Fire enters this older search with special force because it seems to be change itself made visible. Water may flow, air may move, earth may stay, but fire transforms what it touches in a way the eye cannot miss. A flame can make a hard thing soft. It can make a wet thing dry. It can make a dark thing bright. It can turn one surface black and another surface shining. It can make a cold room habitable. It can make ore release metal. It can make clay become vessel. Fire shows the world refusing to stay in one state. So when Heraclitus uses fire, he is not choosing an arbitrary image. He is choosing the element that most clearly refuses rest. This does not mean that every earlier thinker was preparing for him, or that philosophy moves in a simple straight line. It does not. The early Greek world is fragmentary, local, poetic, argumentative, and full of lost works. But from a distance, one pattern is plain. These thinkers were trying to understand change without letting the world fall into nonsense. That is the need fire answers. Fire suggests that change can have a shape, and that becoming can be measured instead of dismissed as confusion. It also suggests that what vanishes may still belong to an order. Among the early Greek philosophers, Heraclitus of Ephesus is the one most closely associated with fire, change, and hidden order. He lived around 500 BCE, though much about his life is uncertain. He wrote in a compact, difficult style. His surviving words come down to us in fragments, quoted by later writers, translated and interpreted in different ways. Even in antiquity, he had a reputation for obscurity. That reputation can tempt us to make him simpler than he was, as if he only said that everything changes, or that everything is fire. But the stronger reading is quieter and more interesting. Heraclitus seems to be asking how a world of change can still be ordered. He is pointing at pattern within movement. A river is a helpful image. The river remains recognizable as a river, even though the water passing through it is always new. If nothing changed, it would not be a river. It would be a pond, or a dry bed, or something else entirely. Its identity depends on flow. Fire has a similar power as an image. A flame is itself only by consuming and changing. Oil becomes light. Wood becomes heat, smoke, ash, and gas. The visible form remains for a while, but never by staying still. It persists through exchange. Heraclitus uses fire in this kind of way. In one famous fragment, he compares the exchange of all things for fire to the exchange of goods for gold. The point is not simply that everything is a lump of fire in disguise. The point is that fire shows a law of exchange. It is a measure of transformation. We do not need to chase every scholarly debate. We can hold the central idea gently. Heraclitus saw the world as a place of ordered change, and fire gave him a vivid way to speak about it. This matters because the ordinary mind often wants stability to mean stillness. We want a thing to be real because it stays the same, but Heraclitus asks us to notice another kind of stability. A stable pattern can exist through motion. A melody exists through changing notes. A river exists through flowing water. A flame exists through fuel becoming light. That is a deep metaphysical thought, and it is also a very simple thing to see. Look again at the small flame. It is not a stone. It does not rest in one position. It is a continuous arrival and departure. Its being is not separate from its becoming. Heraclitus also spoke of the logos, a word that can mean account, reason, word, or ordering principle. The important point for our quiet path is that change is not mere randomness. The world may be difficult to understand, but it is not simply shapeless. It has an order that most people miss because they look at things too quickly or with too much confidence in what they already think they know. One brief fragment says, "Nature loves to hide." That is a useful thought here, because fire both reveals and hides. It reveals the room while hiding its own exact nature. It lets us see other things, but it flickers away from definition. To an ancient thinker, it could be element, sign, soul, godlike process, or cosmic measure. To a modern chemist, it becomes a process of combustion, heat, and light. The flame has not changed its behavior because our explanations changed, but our attention has deepened. Heraclitus is not relaxing in the modern sense. He can be severe, sharp, and difficult. Yet for our purposes, he teaches a calm lesson. Do not assume that change destroys order. Sometimes change is the way order appears. A banked fire is not the same from one minute to the next, but the keeper can still tend it. A river does not contain the same waters, but the traveler can still cross it. A life is never exactly the same as it was yesterday, but it can still have shape. This is the first philosophical fire in the larger elemental path, not the fire of spectacle, but the fire of measured transformation. Heraclitus is especially useful because his fire does not sit still in a category. It is not only a substance, it is not only a symbol, it is not only a physical flame. It is connected with a world in which opposites belong together and change has measure. The sleeping listener does not need a full scholarly lecture on every fragment. We can give the feeling of Heraclitus's thought by returning again and again to controlled paradox. The road up and the road down may be one road. The bow and lyre may hold harmony through tension. The river remains by flowing. The flame persists by consuming. Such examples need care because translations and numbering vary. The point is not to build everything on one fragile quotation. The point is to show how fire helped Heraclitus think about ordered instability. A modern listener may hear change and think of disorder, loss, or restlessness. Heraclitus gives us another possibility. Change may be lawful. Change may be proportioned. Change may reveal the hidden structure of a thing. Think of a hearth again. Too little fuel, and the flame fades. Too much fuel at once, and it smokes or overwhelms the small fire. Too little air, and the flame gutters. Too much wind, and it may scatter sparks. A steady fire is not a fire without change. It is change held in relation. That is the Heraclitean mood we want. Not flames racing across a field, but a measured burning. The word measure is important. It lets us keep fire calm. Fire in Heraclitus is not mere excess. It is exchange according to measure. The phrase can become a quiet anchor because it connects metaphysics to something visible. A flame takes and gives. It changes fuel into light and heat. It does so under conditions. It has rhythm, proportion, and limit. This also lets us avoid a common mistake. We should not present Heraclitus as a prophet of modern energy theory or chemistry. He is not saying what a modern physicist would say. He is giving a philosophical account in the language of his world. The bridge is not identity. The bridge is analogy. Fire helped him think because it showed transformation without pure chaos. After Heraclitus, the old idea of fire takes another important form in Empedocles of Acragas, in Sicily. Empedocles lived in the 5th century BCE. Like many early Greek philosophers, he is difficult to fit into modern categories. He was a poet, a thinker about nature, a religious thinker, and in later tradition, a figure surrounded by legend. Modern scholarship often places him between mythos and logos, between religion and science. That phrase is useful because it reminds us not to force him into one narrow box. Empedocles is especially important for this elemental path because of his doctrine of the 4 roots. The roots are fire, air, earth, and water. They are called roots rather than elements in some discussions, because Empedocles' own language is older than the later textbook tradition. It is something from which things grow. It suggests depth, origin, and hidden nourishment. In Empedocles' system, the visible world does not come from nothing, nor does it vanish into nothing. Instead, things pass away through mixture and separation. The roots combine in different proportions, then come apart again. Behind the changing forms of plants, animals, stones, bodies, clouds, and seas, the roots endure. 2 forces govern this drama: love and strife. Love brings the roots together, while strife separates them again. Neither is simply a small human emotion enlarged to cosmic size. They are ways of naming the principles by which things combine and divide. In one phase, the roots are drawn into harmony. In another, they are pulled apart. The world becomes a rhythm of gathering and release. This is a very sleep-friendly idea when told gently. It does not have to become dramatic. It can be imagined as a slow breathing of the cosmos. Fire joins water, air, and earth in certain mixtures. Later, the mixture changes. Forms appear for a while. Fire in Empedocles is no longer the single image of change that it was in Heraclitus. It is one of several enduring roots. It has power, but it shares the world with the others. This gives us a more balanced picture. Empedocles also gives us a gentle way to think about difference. The four roots do not all do the same work. Fire is not water. Water is not earth. Air is not fire. Earth is not air. Their difference matters. A world made only of brightness would not be a world of rivers, soil, bodies, and breath. A world made only of solidity would not move, flow, warm, or breathe. Mixture lets difference remain difference while still making a shared world. This is a restful thought when spoken slowly. Things do not have to become identical in order to belong together. They can be joined in proportion. A body can be warm and moist, solid and breathing, fragile and enduring. A landscape can hold stone, mist, stream, and sunlight. A hearth can contain earth in the clay or stone, air in the draft, water in the steam from a pot, and fire in the flame. The old roots are not modern chemistry, but they are an old grammar for noticing that the world is many things at once. Love and strife deepen the grammar. Without joining, nothing complex could appear. Without separation, nothing distinct could remain. If everything were only gathered, difference would vanish. If everything were only divided, no living form could hold together. The world of experience requires both nearness and apartness. This is why Empedocles is such a useful doorway into a larger elemental path. He does not give us isolated symbols. He gives us relation. Fire matters because it is not alone. A flame alone does not make a living world. The lamp needs oil. The hearth needs wood. The tree needs earth, water, air, and sunlight. The body needs warmth, breath, moisture, and solidity. Empedocles' four-root theory is not modern chemistry, but it is an attempt to honor plurality within change. This is where fire quietly meets the other elements. Water will become flow, depth, life, and dissolution. Air, and later wind, will become breath, invisibility, motion, and the medium that surrounds life. Earth will become weight, place, stability, soil, body, and matter. Fire becomes heat, transformation, brightness, appetite, and separation. Together, the four elements form one of the most durable symbolic and philosophical systems in Western history. Even after chemistry replaces them as physical explanations, it is important to speak carefully here. Empedocles was not using the periodic table. He was not naming oxygen, carbon, silicon, iron, or hydrogen. He was not doing chemistry in the modern laboratory sense, but he was trying to solve a problem that remains recognizable. How can a changing world be made from something stable? If everything changes completely, how is knowledge possible? If nothing changes at all, how is experience possible? Empedocles answers by saying, in effect, that the deeper constituents endure while their mixtures change. Birth and death, growth and decay, are rearrangements. The roots remain, but the visible form passes. A hearth gives us a simple image. Wood, flame, smoke, ash, heat, and air are not random to the eye. They pass into one another through a visible process. A person who watches long enough may begin to think that all things are mixed, separated, and mixed again. The thought is old but not sleepy because it is dull. It is sleepy because it is wide and slow. Fire becomes one root among others, a participant in the long mixing of the world. Empedocles gives the story its first large shift in atmosphere. With Heraclitus, fire can seem central. With Empedocles, fire takes its place among companions. This is a useful, emotional change. The listener moves from one flame to a table of four quiet presences: a lamp, a bowl of water, a stone, and the air moving a piece of cloth. Nothing needs to happen quickly. The four roots can be imagined as a still life. Fire is brightness and heat. Water is coolness, flow, and depth. Air is breath, motion, and invisibility. Earth is weight, stability, and body. These are not chemical definitions. They are experiential anchors. They arise from the way the world meets the senses. Empedocles' system is especially helpful because it preserves difference. The world is not only fire, it is not only water, it is not only air or earth. It is made of mixtures. Everything visible is a temporary arrangement. That idea gives us sleek, friendly repetition, mixture and separation, gathering and loosening, love and strife. Roots remaining while forms pass. The same thought can be approached through soil, rain, smoke, breath, bone, leaf, ash, and flame. A piece of wood near the fire is a small lesson. It grew from earth, water, air, and sunlight, then dries near heat until its surface is ready to burn. When it catches, it releases heat, gives off smoke, and leaves ash behind. Modern science would explain this in terms of cells, carbon compounds, oxygen, gases, and energy. Empedocles would not. But both the ancient and modern accounts are responding to visible change. Empedocles can feel generous here. His world is not a single principle crushing all others. It is a world of plurality with forces that bring together and pull apart. That makes his thought a natural bridge to water, air, and earth. We can quietly tell the listener that fire is only the first doorway. The early Greek thinkers did not divide the world exactly as we do. A person could write in verse, speak of divine powers, and still offer a serious theory of nature. A thinker could use names that sound mythological to modern ears, while also trying to explain how bodies mix, separate, and change. This is important for Empedocles, but it also matters for the whole history. We do not have to choose between myth and science too quickly. In the older world, those categories had softer edges. Poetry could carry argument. Sacred language could appear beside observation. A natural theory could still be expressed through gods, roots, forces, and cosmic cycles. That does not mean every category should blur together. Careful distinctions still matter, but old thought often lives at a threshold. It wants to know what nature is, but it does not always speak in the plain prose of a modern textbook. Fire is especially suited to this threshold. It is physical and symbolic at once. It can cook a meal and stand for divine presence. It can harden clay and become a metaphor for soul. It can burn a field and become an image of cosmic renewal. It can be measured by chemistry and still haunt poetry. This helps the history stay fair. Ancient thinkers were not modern scientists, but they were also not merely telling decorative stories. They were working with the intellectual tools of their worlds. The phrase to return to is, we can respect the old question without accepting the old answer as modern science. Fire can also quietly gesture toward the other elements without hurrying away from itself. Fire is our beginning because it makes change visible. Water will later let us think about flow, depth, dissolution, and life. Air, or wind in the language of the title, will let us think about breath, invisibility, motion, and the unseen medium around living things. Earth will let us think about weight, stability, place, body, soil, and matter. But fire comes first, because it refuses stillness. It lets the listener imagine transformation happening at the edge of the hand. A piece of wood does not stay wood. Oil does not stay oil. A dark room does not stay dark. The world before the flame and the world after the flame are not the same. The order is not arbitrary. Fire begins because it makes change visible. The four elements become four doors into one old question. What is the world made of, and why does it change? The old answers differ from modern science, but the question remains large, simple, and strangely restful. With Plato, fire enters a different atmosphere. The tone changes from fragment and poem to dialogue and cosmic order. In the Timaeus, Plato gives one of the most influential ancient accounts of the cosmos as an ordered whole. It is not an easy work. It blends mathematics, metaphysics, theology, natural philosophy, and mythic language. But for a quiet history at night, it can be approached gently. The important thing is that Plato does not treat the world as mere accident. The world in this account is shaped according to order, proportion, and intelligibility. Fire belongs to that order. In the Timaeus, the elements are connected with geometric forms. Fire, air, water, and earth are not just everyday substances. They are given mathematical structure. Fire is associated with the sharpest and most mobile of the regular forms in this ancient scheme. The details can become technical very quickly, and we do not need to linger over all of them. What matters is the philosophical movement. Fire is being placed inside a universe that can be understood by reason. This is different from simply watching a flame and wondering at it. Plato asks how a world of visible things might be shaped by invisible order. The flame on the table becomes part of a larger question. Why is the world intelligible? Why do patterns repeat? Why does change not dissolve into pure confusion? Why can the mind recognize proportion in things outside itself? Fire is useful for Plato because it is bright, quick, and penetrating. It allows sight. It belongs to visibility. It also suggests motion and transformation. But Plato's fire is not just a household blaze. It is part of an attempt to think about the body, the cosmos, and the relation between sensible things and rational structure. For a listener at night, this can be softened into one image, a small lamp beside a page of geometry. The flame moves. The drawn shape stays still. One belongs to flicker, the other to proportion. Yet in Plato's imagination, the changing visible world somehow participates in a deeper order. The flame is not outside reason. It is one of the ways reason becomes visible. This does not mean that Plato's ancient physics is modern science. It is not. But it is an important step in the history of fire because it gives fire a place in a rational cosmos. The older hearth taught care. Heraclitus's fire taught change. Empedocles' fire taught mixture. Plato's fire teaches order. The flame is no longer only what consumes wood or lights the room. It becomes a clue to the structure of things. We can imagine someone in an ancient room watching a lamp while thinking of the heavens. The lamp is near, the stars are far. Both are lights, though of very different kinds. Both invite questions about visibility and order. The small fire makes the page visible. The stars make the night seem patterned. The mind moves between them. This is one of the quiet beauties of ancient natural philosophy. It may be wrong in many of its physical details, but it is rarely trivial. It tries to hold together what the modern world often separates: body and cosmos, craft and mathematics, sight and thought, the lamp in the room and the order of the sky. Fire becomes a bridge between the seen and the intelligible. Plato needs a gentle approach because the Timaeus can become dense. It is not a geometry lesson. It is more like a night table with a lamp, a few drawn shapes, and a mind trying to believe that the world is intelligible. A useful way to frame this section is to ask, what if visible change has an invisible grammar? The flame moves, but perhaps it moves within order. The body changes, but perhaps it is composed according to intelligible principles. The cosmos appears vast and varied, but perhaps it is not random. In Plato's Timaeus, fire belongs to a larger account in which the world is shaped, ordered, and proportioned. The elements are associated with geometrical structures. Fire is not merely a practical flame. It is part of an attempt to explain how the sensible world can have rational form. We can linger over the difference between the lamp and the diagram. A flame on the table is restless. The drawn triangle is still, yet both belong to the same active attention. The flame makes the drawing visible, and the drawing offers a way to think about the flame. That image is strong because it lets the scene stay quiet. A person sits at night. The small fire gives enough light to see an outline. The outline suggests that change might not be shapeless. The room is quiet. The mind tries to bring the flickering visible world into relation with an invisible order. This is Plato's gift to this quiet history, not the modern truth of his physics, but the seriousness of the question. Why is nature intelligible at all? Why can the mind search for form in a world that never stops changing? The answer in the Timaeus is ancient and complicated. The idea can remain simple. Plato makes fire part of a cosmos that can be thought. A useful way to deepen Plato's section is through sight. In ordinary life, fire lets us see. A lamp does not only warm the table, it reveals the table. It brings edges out of darkness. It makes color possible after sunset. It turns a page from a pale object into something readable. For ancient philosophers, sight often carried philosophical weight because it seemed to connect the mind with order beyond itself. It became a metaphor for knowing. Light made the world available. In the Timaeus, Plato's account of fire belongs to a larger cosmology, but the simple lamp can help the listener approach it. Fire is related to visibility, perception, and order. It is not simply the blaze and the hearth. It is tied to the possibility that the world can appear intelligibly to the mind. The scene can slow down here. A lamp sits beside a diagram. The flame moves. The line remains. The moving flame makes the stable line visible, and the stable line gives the moving flame a place in thought. This image says more than a technical explanation would. It lets the listener feel how Plato's fire can belong to order rather than chaos. We do not make the Timaeus too clean. It is not a modern scientific work. It is a philosophical cosmology, complex and strange and influential. We can say this gently. The Timaeus is not a laboratory report. It is an ancient attempt to tell why a changing visible world can be thought at all. That distinction keeps the section honest. Aristotle gives fire another kind of order. Where Plato often moves toward mathematical form, Aristotle looks closely at qualities, causes, and changes in the natural world. On generation and corruption, he explains the four elements through pairs of qualities, hot and cold, dry and moist. In this system, fire is hot and dry, air is hot and moist, water is cold and moist, earth is cold and dry. Aristotle's qualities are also bodily, in a way that modern readers can still understand. Hot and dry are not abstract words when a person is standing near a hearth. The heat touches the face. The dryness tightens skin and cloth. A damp sleeve held near the fire becomes lighter. A cold hand slowly opens. A pot begins to tremble before it boils. The rafters above the fire darken over years. The smoke finds its path. The old theory is built from these repeated encounters. It organizes what the senses report. It asks the world to become readable through qualities. That is not the same as asking it to become measurable through instruments, but it is still a kind of order. We can imagine a person in an older household knowing very well that not all heat is alike. Sun warmth differs from hearth warmth. Fever differs from cooking fire. A warm stone differs from a living flame. Dry air differs from dry ash. Moist steam differs from cool water. The ancient qualities are simple, but the world they try to organize is not. This makes Aristotle's fire easier to respect. It is not simply a wrong answer written down by someone who failed to notice the obvious. It is a disciplined answer to a different set of evidence. It belongs to a world where natural philosophy still begins with the sensible qualities of things. Later chemistry will not merely add facts. It will change the trust placed in different kinds of evidence. The balance, the sealed vessel, the collected gas, and the repeatable experiment will begin to speak with new authority. But before that turn, fire remains hot, dry, rising, active, and transforming. This sounds simple, almost like a table in an old textbook. But it was a serious attempt to understand change. If things come to be and pass away, what exactly changes? How can one kind of body become another? How can the world be full of transformation without everything becoming unintelligible? Aristotle's answer is organized around qualities. Elements can transform when qualities are altered. Fire and air share heat, but differ in dryness and moisture. Air and water share moisture, but differ in heat and cold. In this way, transformation can be imagined as a change in qualities rather than an inexplicable leap. Again, this is not modern chemistry. Aristotle is not describing oxygen atoms, carbon dioxide, plasma, or molecular bonds, but he is giving a rational structure to the world available to touch and observation. The hand knows heat and cold. The hand knows wet and dry. The body knows the difference between a damp morning and a dry wind, between warm breath and cold stone, between ashes and water. Aristotle begins with such differences and turns them into a system. Fire, as hot and dry, has a particular behavior in Aristotle's system. It rises upward, gives heat, dries what is damp, and tends toward the upper region of the cosmos. Earth tends downward. Water and air occupy intermediate places. The world becomes a layered order of tendencies. It can be easy to dismiss this because modern physics no longer shares the old theory. But dismissal is not the mood here. A slower kind of attention asks what the theory allowed people to see. Aristotle's fire is not merely mysterious. It has qualities. It has relations. It can become part of a cycle of transformation. It can be compared to air, water, and earth. It can be placed in an ordered world. If Heraclitus gives us fire as exchange and Empedocles gives us fire as one root among others, Aristotle gives us fire as part of a grammar of qualities. That grammar lasted for a very long time. It shaped medicine, alchemy, cosmology, and ordinary explanations of the body and the world. Hot, cold, dry, and moist became a way of talking about health, temperament, food, weather, and matter. Near a hearth, these qualities feel immediate. The fire dries damp shoes. It warms cold hands. It changes the air of the room. It turns green wood smoky and reluctant, while dry wood catches more easily. The ancient theory may not be chemically correct, but it is rooted in the repeated facts of daily experience. The trouble comes when everyday qualities are asked to explain more than they can. Later experiments will show that fire is not an element in the modern sense. They will show that combustion depends on chemical combination, especially with oxygen in ordinary air. They will show that ash, smoke, heat, and flame are not evidence of a simple body called fire moving through the world. But that correction comes later. For now, Aristotle's fire stands in its old place, hot, dry, rising, active, and intelligible within a system of natural change. Aristotle can sound dry in a modern classroom, but for a quiet night, the dryness is useful. It lets the thought slow down into qualities. Hot, cold, dry, and moist become the basic qualities in this older way of organizing nature. They do not begin in a laboratory instrument. They begin in skin, weather, breath, food, and touch. A stone in shade is cold. A hearth is hot. Wet wool is heavy and uncomfortable. Dry straw catches flame. Damp wood smokes. Warm air rises. Ash is dry. Steam is moist. The world announces qualities before it announces equations. Aristotle's system turns those qualities into an explanatory map. Fire is hot and dry. Air is hot and moist. Earth is cold and dry. The elements are related by shared and opposing qualities. So change can be described as a shift in qualities. The important thing is not to ask the listener to believe this as science. The important thing is to show how convincing such a map could feel. In a world where touch, sight, craft, and ordinary experience were primary instruments. A listener near sleep can follow this easily. A cold, wet morning. A hot, dry hearth. A damp log refusing to burn. A pot of water heating, steaming, and disappearing into air. The old system is wrong by modern chemistry, but it is not arbitrary. It is built from repeated contact with the world. This also prepares the later chemistry correction. Aristotle's account organizes experience by qualities. Lavoisier's later account will organize combustion through gases, weights, and chemical combination. Both are attempts to explain transformation, but they ask different questions and trust different kinds of evidence. That contrast will make the oxygen section feel earned rather than abrupt. Aristotle's fire becomes clearer when we give ordinary examples. A dry twig catches more easily than a wet one. Damp wood smokes before it burns. A warm room dries cloth. Ash left by fire is powdery and dry. Heat rises from the hearth and gathers under the roof. Water near the fire warms, steams, and disappears from the pot. These observations do not prove Aristotle's element theory, but they help explain why the theory could feel connected to the world of experience. Hot and dry were not random labels. They named recurring features of fire as people encountered it. We can inhabit that world for a while. There is no thermometer, no oxygen sensor, no periodic table. There is the hand, the eye, the nose, the repeated work of cooking and heating and drying, and the memory of what tends to happen. This does not make the old theory true. It makes it human. That distinction matters. We do not want to sneer. Later, when we reach Lavoisier, the listener will feel the shift in evidence. The hand and eye remain, but now the balance becomes central. Weight matters because heated substances sometimes become heavier. Closed vessels matter because they limit the air around a flame, and gases matter because different kinds of air affect burning differently. What disappears from sight may still be present in another form. What seems to be lost may have combined with something invisible. Lavoisier gives us measurement. Both belong to the long effort to understand transformation. The Stoics inherit earlier Greek thought and reshape it into one of the most influential philosophical systems of the ancient world. For them, Fire is not only an element among other elements, it is connected with activity, reason, breath, and the living order of the cosmos. The Greek word pneuma can mean breath, wind, or spirit-like vital force, depending on context. In Stoic physics, pneuma helps explain how things hold together, how bodies are structured, and how the cosmos is alive with order. This can become technical, so it is enough to keep it quiet. Imagine breath on a cold night. It is invisible in the body, then visible for a moment in the air. Breath warms and moves as it comes and goes, connecting inward life with the outward atmosphere. Fire warms the space around it, moves upward through the air, and transforms the matter that feeds it. It makes hidden energy visible. For the Stoics, the active principle in the cosmos could be described in fiery and breath-like terms. Their world is not a dead collection of objects. It is ordered, rational, and pervaded by an active principle. Fire and pneuma are ways of speaking about that activity. This is not the same as modern oxygen chemistry, and it cannot be flattened into modern ideas. Stoic fire belongs to Stoic physics and theology. It is part of a complete view of nature, fate, reason, and human life. But it has a place in our history because it shows fire moving from household and element into a cosmic principle of organization. Fire, for the Stoics, is not merely destructive. It is generative, structuring, and living. It is linked with the order that makes the world a cosmos rather than a heap. That word cosmos matters. It suggests order, arrangement, beauty, and world. The same flame that can consume a house can also become, in philosophy, an image of reason's active presence. The Stoic connection between cosmic order and human life gives this section a gentle ethical quality. If the world has order, then the wise person tries to live according to nature. The point is not to become fiery in a dramatic, emotional way. It is almost the opposite. It is to understand the order of things, to consent where one must, to act where one can, and to keep the inward flame steady. The image is not a bonfire. It is a lamp protected from wind. The Stoic flame is disciplined. It belongs to a world of endurance, measure, and breath. With the Stoics, the room opens to the night air. Until now, we have spent time with hearth, lamp, root, quality, and ancient geometry. With the Stoics, fire becomes more explicitly cosmic and living. The key is not to overstate or modernize. Stoic pneuma is not simply oxygen, and Stoic fire is not electricity, plasma, or modern energy. It belongs to a different physics, but the language of breath and fire gives the listener a bridge into the Stoic imagination. Breath is invisible until conditions reveal it. On a cold morning, a person breathes out and sees a pale cloud for a moment. Then it disappears. Breath is intimate, but it belongs to the air around us. It is inside and outside. It is movement and life. It is ordinary, and yet it can feel close to mystery. Fire works in a related way. It makes activity visible. It warms, rises, consumes, and organizes a small center of brightness. To imagine the cosmos as pervaded by a fiery, breath-like ordering principle is not to imagine a dead universe. It is to imagine a living order. This can breathe slowly, a small flame on a desk, a cloth moving near an open window, the dark sky beyond, the lamp's warmth near the hand. These images let pneuma become understandable without turning the section into terminology. Stoicism also gives this quiet history a moral tone. Fire is active, but the wise person is not frantic. Breath moves, but the wise person practices steadiness. The world is ordered, but not according to private preference. The task is to live in accordance with nature, which means accepting the larger order, while acting with discipline in one's own place. That idea pairs well with a protected flame, not a wildfire, not a furnace roar, not the sudden spark, but a lamp kept steady despite air moving around it. This image can foreshadow the later safety lamp. In both cases, flame needs a form. A philosophical life needs discipline. A mind lamp needs gauze. A ritual flame needs rules. A household fire needs a hearth. Fire becomes most useful when its power is joined to order. Fire also belongs to ritual. Here we need to be especially careful. It is easy to use sacred fire vaguely, as if every tradition meant the same thing by flame. That would be careless. The better approach is to move slowly and respectfully, using specific sources and avoiding broad claims. One important example is Zoroastrian fire. In Zoroastrian tradition, fire has a central ritual place and is associated with purity, presence, and reverence. It is not well served by the simple phrase, fire worship, because that wording can mislead. The fire is sacred, carefully tended, and symbolically powerful, but the tradition is more complex than outsiders often make it. What matters here is the kind of attention fire receives. A sacred flame is not treated like an ordinary tool. It is kept clean. It is approached with ritual care. Its continuity matters. Its brightness is not just useful illumination, but part of a disciplined relationship between human beings, purity, worship, and the sacred. This is different from the philosopher's fire, but not completely separate from it. Both ask people to attend. Both treat flame as more than accidental brightness. Both see in fire a relation between visible and invisible order. A flame that must be kept is a flame that binds one day to another. Its tending becomes routine, and routine becomes meaning. Someone must prepare, clean, watch, feed, and protect. The fire becomes a center around which human action is organized. This belongs naturally here because these quiet histories often return to ordinary routines. A lighthouse keeper tending a lamp. A medieval household banking embers. A caretaker maintaining a quiet place through the night. Sacred fire gives that ordinary act another dimension. Tending is no longer only practical, it is devotional. We do not need to dramatize it. We can simply imagine the clean chamber, the vessel, the flame, and the careful movements around it. Fire here is not wild, it is disciplined brightness. It asks for purity, attention, and continuity. Sacred fire needs quiet precision. We cannot pretend to summarize all religious uses of fire. Instead, one carefully sourced example can show a general human pattern. Flame invites care. Zoroastrian fire is especially important because it is not a casual symbol. Fire has a central place in ritual life and is associated with purity, attention, and sacred presence. It is better to avoid saying that Zoroastrians simply worship fire, because that phrase has often been used in a flattening way by outsiders. Better language is that fire is revered, ritually tended, and symbolically central. This gives the history a new kind of slowness. The fire is no longer only a philosophical image or practical tool. It becomes a responsibility. To keep a flame clean is to arrange behavior around it. To approach a flame ritually is to slow the body. To tend a flame across time is to make continuity visible. We can imagine careful movements without inventing details beyond the sources. A clean vessel, a flame protected from impurity, a chamber arranged around attention, a light that is not simply grabbed for use, but approached with respect. This also connects gently to the lighthouse work we just completed. A lighthouse lamp was not sacred in the same sense, but it was also tended through routine. Its trustworthiness mattered. It had to be cleaned, fed, watched, and protected. Different kinds of fire ask for different kinds of fidelity. That parallel matters for the tone of the night. These quiet histories often find meaning in repeated care. Fire makes that especially visible. It rewards attention and punishes neglect. In a sacred setting, that attention becomes part of a larger relationship between people, purity, worship, and the unseen. We are explaining historically, not preaching. Around sacred fire, we slow down around the word purity. Purity can mean many things in different traditions. It may refer to ritual cleanliness, moral symbolism, cosmological order, or the proper separation of what should not be mixed. It is not a vague emotional glow. In the Zoroastrian context, fire is associated with purity and has a central ritual role. But we should not explain more than the sources support. We are not making a theology lecture. We are marking the historical fact that fire can be revered, protected, and approached through rule-bound care. The sacred flame is not important because it is large. It is important because it is tended. That keeps the tone gentle. It also connects sacred fire back to ordinary routines. A large blaze may impress the eye, but a tended flame changes the day. It asks for preparation. It asks for cleanliness. It asks for continuity. This belongs to the broader quiet pattern. There is often meaning in maintenance. The lamp keeper, the scientist checking instruments, the craftsperson returning to the bench. Sacred fire is another kind of maintenance, but directed toward reverence. Careful language is part of the calm. Instead of collapsing many traditions into one, we stay with particular traditions, particular practices, and cautious phrases. In the furnace, fire becomes a partner in experiment. The hearth keeps a household warm. The lamp gives light. The ritual flame is tended with reverence. The furnace asks a different question. What can fire make matter become? Furnaces belong to metallurgy, ceramics, glassmaking, and many kinds of craft. They also belong to alchemy and early laboratory practice. In these settings, fire is controlled, concentrated, and watched. It is not enough to say that something burns. One must know how hot, how long, in what vessel, with what fuel, under what conditions, and with what signs of change. A quiet, alchemical room is a good image for this stage of the history. Not a fantasy chamber, and not a room of theatrical magic. Just a workbench, a small furnace, vessels, tools, charcoal, ash, glass, metal, and notes. The flame is hidden partly inside the apparatus. Its effects appear slowly. Materials darken, brighten, melt, harden, evaporate, condense, separate, combine, or leave residue. The worker watches color, texture, smoke smell, weight, and timing. Some interpretations may be symbolic, some may be practical, some may be wrong, but the attention is real. Alchemy is not just foolishness. It was a historical mixture of craft, experiment, medicine, metallurgy, cosmology, and spiritual language. It preserved techniques and habits of observation that helped prepare later laboratory science, even when its theories do not match modern chemistry. Fire in this setting is the agent of transformation par excellence. It does not merely symbolize change, it makes change happen under the eyes of the worker. Calcination, distillation, sublimation, melting, roasting, and refining all depend on heat and controlled conditions. The furnace becomes a small world where matter is asked to reveal its hidden possibilities. This leads toward the turning point of the story. For a very long time, fire seemed like one of the basic realities of nature. But in the laboratory, fire also began to undermine that idea. The more carefully people studied flame, air, smoke, metals, gases, and weight, the harder it became to keep calling fire an element. The flame that once explained transformation gradually became something that needed explaining. The furnace is where fire becomes hidden and intensified. At the hearth, flame is visible and domestic. At the lamp, flame is small and clear. In the furnace, fire is partly enclosed. One sees its mouth, its glow, its heat, its effects, but not always the whole process. This makes the furnace a perfect image for early experiment. The worker prepares materials, seals or opens a vessel, adjusts fuel, waits, and watches for signs. Color changes, smoke, odor, and residue all matter because each one is a sign that heat is changing the material. Weight matters too, though weight will become far more important in the chemistry to come. Alchemy belongs here because it takes transformation seriously. It may interpret transformation through symbols and theories that modern chemistry no longer accepts, but its practices often involved patient observation. Heating, cooling, grinding, dissolving, filtering, distilling, and repeating were all ways of asking matter what it could become. It is tempting to make a cheap joke here, but that would miss the point. Alchemy is not a punchline. Alchemy is a historical ancestor and neighbor to chemistry, not simply its foolish opposite. Its language can be strange to modern ears, but its rooms were filled with real materials and real fire. There is a deeply sleepy rhythm in this section. The furnace is prepared, the coals are arranged, and the vessel is set carefully in place. Heat rises slowly, and for a while nothing seems to happen. Then a surface darkens, a vapor appears, a drop condenses, a powder changes color, or a metal softens. The transformation is not instant. Fire works in time. This lets the history broaden without becoming dramatic. Ceramics, metallurgy, glassmaking, distillation, calcination, and refining all show different ways humans learn to use controlled heat. Each example shows fire as a collaborator with patience. The alchemist and the craft worker are not merely asking what fire means. They are asking what fire does under conditions. That question points toward the laboratory. The early laboratory can be described as a new kind of hearth. It still has flame, it still has vessels, it still has heat, waiting, residue, and transformation. But the purpose changes. The fire is no longer only to cook, warm, worship, or craft. It is there to ask repeatable questions. What happens if this metal is heated in a closed vessel? What gas is released? What happens to the weight? What kind of air supports flame? What kind of air extinguishes it? What remains after burning? These are quiet questions, and they fit the pace well. They can be asked slowly, almost like a list of experiments laid out on a bench. The laboratory hearth is more suspicious than the household hearth. It does not trust appearance alone. If something seems to vanish, the chemist asks where it went. If a metal becomes heavier after heating, the chemist asks what it gained. If a candle goes out in one jar and burns brighter in another, the chemist asks what is different about the air. It also treats science as a change in habits of attention, not merely a list of names. The point is not only that Priestley and Lavoisier did important work. The point is that fire was placed in a new kind of room under new expectations. The flame was no longer allowed to be only symbolic. It had to answer to the balance, the vessel, and the repeated test. Fire also taught through danger. This part of the story is best told quietly. We are not using accidents for excitement. We are noticing how risk can force attention. When flame behaves unexpectedly, people must ask better questions. One example comes from mines. In coal mines, invisible flammable gases could gather underground. Fire damp, largely methane mixed with air, could be ignited by an open candle or lamp. A miner needed light to work, but that light could also trigger explosion. This was not a philosophical puzzle in the abstract. It was a practical danger. The question became urgent. How can one carry flame into a place where flame may ignite the air itself? Humphrey Davy's safety lamp is one answer. In 1815, after serious mine explosions drew attention to the problem, Davy developed a lamp in which the flame was enclosed by fine wire gauze. The openings allowed light and air, but the metal absorbed heat and prevented the flame from passing outward to ignite surrounding fire damp under proper conditions. This is a beautiful example of fire knowledge becoming applied science. The lamp did not deny fire. It understood fire more carefully. A flame needs heat to continue and to spread. If enough heat is drawn away at the boundary, the flame cannot pass through. The metal gauze becomes a quiet line between useful light and disaster. There were later complications, especially with air currents and changing mine conditions. But the central lesson remains. Dangerous fire made people study flame, gas, heat, and containment with new seriousness. This belongs in a history of fire because it shows a bridge between metaphysics and experiment. The old question was, what is fire? The practical question became, how exactly does fire move, spread, breathe, and stop? An accident does not automatically create knowledge. Many accidents only injure, frighten, or destroy. Knowledge comes when people investigate carefully afterward, compare cases, test conditions, and build better explanations. That is the sober thread here. Fire draws attention because it can harm. But attention, disciplined and repeated, can turn danger into understanding. This section stays sober and low. The subject includes death and injury, but we do not turn suffering into spectacle. The purpose is to show that fire sometimes became better understood because people had to understand it. In mines, flame was necessary because darkness was dangerous. But flame could also become the danger. Fire damp could gather invisibly, and an open light could ignite it. A candle that meant visibility in one moment could mean catastrophe in the next. That contradiction is powerful. The tool of safety becomes the source of danger. Humphrey Davy's safety lamp belongs here because it transforms this contradiction into a physical design. The lamp does not remove fire from the mine. It disciplines fire. The wire gauze allows air and light but draws away heat, stopping flame from passing through under the right conditions. The idea is simple enough for a sleepy listener and deep enough to matter. Flame is not merely a shape. It is a process needing heat, fuel, and surrounding conditions. Change the boundary, and the flame behaves differently. We can describe the lamp on a table before describing it in a mine. A small flame inside a gauze cylinder. The image is simple. Metal mesh around light. A visible flame held inside a careful boundary, and darkness waiting nearby. Coal dust on the bench. A tool made from fear, experiment, and care. Such inventions did not make mining safe in any total way. They reduced particular risks under particular conditions, and the history of safety is always more complicated than one device. That caution keeps the history honest. The broader point is that fire taught not only through philosophy, but through limits. A flame could not be understood only by looking at it in the open air. It had to be watched in vessels, mines, lamps, furnaces, enclosed spaces. Under each condition, It revealed a different rule. The Davy lamp can do more than fill a historical segment. It can carry a moral of the story. Fire becomes safer when understood as conditional. A flame is not danger in every circumstance. A mine atmosphere is not danger in every circumstance. But the wrong flame in the wrong air under the wrong conditions can become deadly. The lamp is a tool for respecting conditions. It does not pretend danger is gone. It creates a controlled relation between flame and surrounding air. This gives us a bridge back to ancient philosophy. Heraclitus used fire to think about measure. The safety lamp uses measure physically. The wire gauze, the size of openings, the cooling of flame, the containment of heat. All of these are measures. The device does not need to be over-poeticized, but the connection is real enough. An old metaphysical word, measure, becomes a practical engineering principle. The flame must be held in proportion to its surroundings. That is true at the hearth, in the mine, and in thought. So how did scientists learn that ordinary fire needs oxygen? The careful answer is that they did not discover it all at once. It was not one simple accident that suddenly revealed the truth. It was a chain of experiments with air, flame, metals, gases, and weight. For a long time, the dominant explanation of burning in European chemistry involved phlogiston. In that theory, combustible things were thought to contain a fire-like principle that was released during burning. Air mattered because it received or became saturated with this released principle. The theory could explain some observations well enough to remain persuasive, but it began to struggle as experiments grew more precise. Several researchers worked with different kinds of air. The old idea that air was a single simple substance became harder to maintain. There were airs that put out flame, airs that harmed breathing, airs that came from fermentation, airs that burned, and airs that made burning more intense. Carl Wilhelm Scheele produced a gas he called fire air. Joseph Priestley isolated the gas we now call oxygen in 1774 by heating red mercuric oxide with focused sunlight. In his tests, the gas allowed a candle to burn with unusual brightness and supported life longer than ordinary air. Priestley did not call it oxygen. He called it dephlogisticated air because he still interpreted it through the phlogiston theory. That is an important detail. A person can make a discovery and still explain it in an older language. Lavoisier then reinterpreted such evidence. Through careful experiments, weighing, and a new theoretical framework, he argued that combustion was not the release of phlogiston, but a combination with a part of the air. That part came to be called oxygen. The modern explanation can be stated simply. Ordinary fire needs fuel, heat, and an oxidizer. In everyday fires, oxygen in the air is the familiar oxidizer. If a flame is enclosed and consumes the available oxygen, it goes out. If it is given oxygen-rich air, it may burn more vigorously. If fuel, heat, or oxidizer is removed, the fire cannot continue. This does not make the ancient reflections worthless. It changes the level of explanation. Heraclitus was not doing gas chemistry. Empedocles was not isolating oxygen. Aristotle was not using a balance to measure combustion products. They were asking about change, order, mixture, and qualities. Later chemists asked what substances were actually present, what combined with what, and how mass was conserved. The flame remained the same ordinary wonder, but the question changed. Fire was no longer one of the basic elements. Fuel combines with oxygen. Energy is released, heat and light appear, and new substances form. Smoke, ash, carbon dioxide, water vapor, soot, and many other products may appear depending on the fuel and conditions. Fire in modern chemistry is transformation indeed, but not in the old elemental sense. It is change made visible through reaction. The oxygen story becomes clearer when we imagine the air itself becoming strange. For everyday life, air seems invisible and simple. It is just there. A person breathes it without thinking. A candle burns in it. A bellows pushes it. A draft moves it through a room. But in the 18th century study of gases, air began to divide into different airs with different behaviors. Some airs would not support a flame. Some airs could be breathed only with danger. Some airs came from reactions. Some airs could burn. Some made ordinary flame behave in extraordinary ways. The invisible atmosphere was no longer one simple background, it became a subject of experiment. A candle became a test, not a complete test by modern standards, but a visible sign. If the candle died, the air was different in one way. If it burned brightly, the air was different in another. If an animal could breathe longer, the air seemed unusually good. These old experiments could be harsh by modern standards, and we do not dwell on them. What matters for our purpose is the changing idea of air. Priestley's gas made ordinary fire look newly interesting. A candle that burns brighter is a quiet but powerful observation. It tells the chemist that the flame is not only about the fuel. It tells the chemist that the surrounding air is participating. That participation is the key. The flame is not alone. The fuel is not alone. The air is not passive emptiness. Lavoisier's achievement was not merely adding a new name. It was reorganizing the explanation. Combustion became combination. The old image of a fire principle escaping from matter gave way to a new account in which matter combines with oxygen and changes form. The flame once again became a teacher of relation. Now we can answer the natural question: how did people realize fire needed something in air? Begin with ordinary experience. A candle under a glass eventually goes out. A fire in a closed space becomes smoky, weak, or dangerous. A person knows that air matters, even without knowing what air contains. Bellows make a fire brighter. Wind can either feed a flame or blow it out. A draft changes the behavior of a hearth. These everyday facts prepare the mind for the chemical discovery. Then move to the old theory. Phlogiston theory imagined burning as a release of a fire-like principle from combustible materials. It was not silly by default. It was an attempt to explain why things burn, why metals change when heated, and why air seems to have a limit in supporting combustion. But as experimenters began to isolate different gases and weigh materials carefully, the theory became strained. Scheele and Priestley belonged together, but not as a rivalry story. Scheele produced the gas earlier and called it fire-air. Priestley's 1774 experiment became famous because he heated red mercuric oxide and collected a gas in which a candle burned with remarkable vigor. Priestley still interpreted what he saw through phlogiston language. That detail is one of the most useful teaching moments in the history of fire. A discovery is not always recognized in the language we would use later. The gas was there. The explanation had not yet changed enough. Lavoisier's role is the theoretical term. He used careful measurement and a new framework to argue that combustion involved combination with a part of the air, rather than release of phlogiston. This is where oxygen becomes part of a new chemistry. The modern fire triangle can be very calm. Fuel, heat, oxidizer. Remove one, and ordinary fire cannot continue. Oxygen in the air is the usual oxidizer for everyday fires, though oxidizers more broadly can vary. This keeps the statement accurate without overwhelming the listener. It also creates a gentle bridge between older philosophy and newer chemistry. Ancient philosophers asked what fire is in the order of the world. Early chemists asked what fire consumes, what remains, what gains weight, what loses weight, and what part air plays. The question moved from meaning and quality to measurement and reaction. Fire did not stop being beautiful when oxygen entered the story. It became more specific. The oxygen explanation can stay clear and calm. The path can be told plainly. First, people knew air mattered. Then they learned that air was not one simple thing. Experiments isolated different gases. One of those gases made flame burn with unusual strength. The meaning of that gas was argued over. Lavoisier helped shift the theory toward oxygen and combustion as combination. Modern chemistry now understands everyday fire through fuel, heat, and oxidizer. The ordinary image of a candle returns. A candle in common air burns in a familiar way. A candle in oxygen-rich gas burns more fiercely. A candle with too little oxygen weakens and goes out. This simple comparison answers the user's original question without pretending the history was simple. It lets the audience understand why Priestley's observation mattered. The line is simple. Priestley saw something real, but explained it with an older theory. That line is important because it teaches how science changes. Evidence and interpretation do not always change at the same moment. Sometimes the observation arrives first, and the new explanation arrives through other minds, other instruments, and other arguments. This is a quiet lesson. Knowledge does not always arrive like lightning. Sometimes it arrives like a lamp, slowly brightening. We can be patient with phlogiston, because the word can sound odd to modern ears. Phlogiston theory belongs to the period before modern oxygen chemistry. It tried to explain burning by saying that combustible things contained a fire-like principle released during combustion. In that older framework, a burning candle or a burning piece of charcoal seemed to be giving something off. This was not a foolish thing to ask. Fire does appear to release light, heat, smoke, smell, and visible change. The flame rises from the fuel. Something seems to leave. Something seems to escape. The difficulty came when chemists began weighing materials more carefully and studying gases more systematically. Some metals gained weight when heated. Different airs behaved differently. Some supported flame. Some extinguished it. Some were made by reactions that did not fit neatly into the older explanation. The point stays calm. The old theory was trying to explain real appearances. The new chemistry did not appear because people suddenly became clever and everyone before them was foolish. It appeared because measurements, instruments, and questions changed. That is part of the lesson. Respectful correction is more trustworthy than smug correction. We are moving through a long human effort, not laughing at older minds. Because this history touches fire, lamps, mines, furnaces, and gases, it includes a quiet, safety-minded reminder. Fire is beautiful in memory and thought, but in ordinary life, it remains a real danger, and every useful flame depends on proper ventilation, distance, material, and care. It does not need to become loud. It simply makes clear that we are not romanticizing risk. The same care applies when we reach oxygen. Oxygen-rich environments can make combustion more intense, but this is historical explanation, not a set of instructions. There is no need to explain how to make oxygen, collect gases, or reproduce old experiments. The useful thing is to understand what happened historically. This is educational history, not a demonstration guide. There are no instructions here for reproducing old fire or gas experiments. Even after chemistry changes the explanation, fire keeps its inward power. This is where a modern thinker such as Gaston Bachelard becomes useful, if used gently. Bachelard wrote about fire not as a laboratory chemist, but as a philosopher of imagination, reverie, and poetic experience. Fire for him belongs to the inner life as well as the outer world. We can understand this without making it mysterious. A person can know that a flame is combustion and still be drawn to watch it. Knowing oxygen does not remove the quiet spell of a candle. Knowing chemistry does not stop the hearth from feeling like shelter. Knowing that fire is not an element does not erase the ancient human sense that flame is change made visible. This is one reason the history of fire should not end with correction. The chemical account is true in its domain. The ritual account may be true within a tradition of worship and care. The philosophical account may be true as a way of thinking about change. The poetic account may be true as a description of human attention. These truths should not be confused, but they also do not have to cancel one another. A candle flame in a dark room is still many things at once. It is fuel, vapor, oxygen, heat, and light. It is also a small event of attention. It can stand for memory, waiting, mourning, study, prayer, warmth, danger, or hope, depending on the human world around it. At this point, the story can become especially quiet. The path has passed through philosophers, roots, qualities, sacred flames, furnaces, safety lamps, and oxygen. Now we return to the simple act of watching. The flame bends as air moves through the room, and the room seems to breathe around it. The mind follows that movement and slowly lets go of argument. After oxygen, the story slows down again. The danger is that modern chemistry may seem to have ended the older story. Bachelard helps prevent that by showing that explanation and imagination can coexist. He does not need to be quoted heavily here. We can simply use him as a doorway into the idea that fire remains an object of reverie. A person can understand combustion and still stare into a candle. A person can know that flame depends on oxygen and still feel that fire gathers memory. A person can know that a hearth is a physical heat source and still feel that it changes the meaning of a room. This can be one of the quietest parts of the night. It almost feels like the final descent. The story has climbed through philosophy, ritual, furnaces, minds, and chemistry. Now we return to watching. The candle on a desk does not argue, and it does not demand a theory from anyone watching it. It only moves in small changes of light and heat. The mind, tired from explanation, can rest in that movement. Bachelard's value is not that he replaces science. It is that he notices another human register. Fire is chemical, but human beings do not experience it only chemically. It is also domestic, symbolic, ritual, poetic, and inward. The idea is layers, not contradiction. The chemical account tells us how ordinary flame continues. The historical account tells us how people learn to use and explain it. The philosophical account tells us how fire helped people think about change. The imaginative account tells us why a small flame still holds attention. The story has followed fire through many rooms. At the beginning it was a small flame before philosophy, changing while remaining recognizable. At the hearth it was comfort, danger, tool, and companion. In Heraclitus, it became an image of exchange, order, and becoming. In Empedocles, it became one of the four roots, joining air, water, and earth in the mixtures of the visible world. In Plato, it entered a cosmos shaped by order and proportion. In Aristotle, it became hot and dry, part of a system of qualities and transformations. In Stoicism, it helped describe active reason, breath, and the living order of nature. In ritual, it asked for purity, continuity, and reverent attention. In the furnace, It transformed matter under the worker's eye. In accidents and safety lamps, it demanded respect. In the discovery of oxygen, it ceased to be an element in the older sense and became a process that could be tested, measured, and explained. And after all of that, the flame still moves. It feels quieter now, not because it is less powerful, but because it has been watched long enough to stop asking it to be only one thing. Fire has been a tool, a danger, a symbol, a sacred presence, a philosophical principle, an experimental problem, and a chemical reaction. It has carried human thought from the hearth to the cosmos, from the altar to the laboratory, from the mind lamp to the candle on a desk. Perhaps that is why it remains such a strong image of change. Fire never lets matter remain what it was. It asks for fuel and gives back warmth, light, ash, smoke, and memory. It is never still, but it can be tended. It is never fully safe, but it can be respected. It is never simply one thing, but it can draw many meanings into one small glow. By the end of this quiet history, fire has become almost too many things to hold at once. It is a tool and a danger. It is an ancient element and a modern process. It is a sacred presence in one room and a laboratory problem in another. It is a philosopher's image of change and a chemist's reaction. It is the hearth of a household, the guarded flame of a ritual, the heat of a furnace, the contained light of a safety lamp, and the candle that burns differently when the air around it changes. But no one has to keep all of these meanings in order now. The names can fall away. The systems can fall away. The old disagreements can fall away, while the flame remains in a smaller and lower form. It is almost finished. But in that last small glow, the whole history is still present in a gentle way. The old philosophers watched change. The keepers tended light. And the craft workers learned heat through repeated practice. The chemists studied air, and the poets watched memory gather around a wick. All of them in different rooms were trying to understand why this small brightness changes everything near it. There is only the low hearth, the small ember, the softened room, and the steady dark around it. The fire has done what it came to do. It has changed the room. It has changed the thought. And now it can simply be watched. Heraclitus's flame can be placed back on the table as measured change. Empedocles' flame can return to its companions, water, air, and earth. Plato's flame can rest beside the drawing. Aristotle's flame can warm and dry the room. The Stoic flame can remain steady near the night air. The sacred flame can be tended without needing to be owned. The furnace can cool. The safety lamp can sit on the bench, its gauze visible in the last light. The chemist's candle can burn in clearer knowledge of oxygen. The final hearth can hold all of these without speaking. Fire is a test of every explanation because it is difficult to keep in only one category. A practical person asks whether it will cook, warm, harden, soften, melt, dry, or burn. A ritual person asks how it should be approached, protected, purified, and tended. A philosopher asks what it reveals about change, order, substance, and becoming. A craft worker asks about temperature, fuel, vessel, and timing. A mine engineer asks under what conditions it may ignite the air around it. A chemist asks what combines, what remains, what gains weight, and what gas supports the flame. A poet asks why the small flame holds the mind. None of these questions is identical to the others. The distinction matters. Chemistry, poetry, ritual, and metaphysics are not the same thing. Fire has simply been important enough to attract all of them. Fire answers differently depending on the room in which it is questioned. In the kitchen, it answers with food. In the forge, with metal. In the temple, with reverence. In the philosopher's fragment, with becoming. in the laboratory with oxygen, in the candlelit room with attention. The fire has passed through many rooms. It has been held in clay, stone, metal, glass, gauze, and thought. It has warmed, cooked, dried, hardened, softened, brightened, frightened, purified, transformed, and explained. It has been called an element and then corrected by chemistry. It has been treated as sacred, practical, cosmic, dangerous, domestic, experimental, and poetic. But now the many rooms can go quiet. No one needs to argue with the ember, measure the ember, or name the ember. It simply changes at its own pace as its red color deepens. Its edge darkens. A thin line of heat remains where the wood is almost gone. The room is not bright, but it is not entirely dark. The air is still, and the mind can set down the old systems one by one. Root, element, quality, breath, purity, phlogiston, oxygen, and combustion. All of those names helped someone somewhere hold fire in thought. But the last thing we hear is not a name. It is only the small sound of a low flame and the quiet patience of light becoming ash. And for a little while there is nothing more to explain, only the ember, the warmth, and the quiet change of light.